in 2004 to 2008 when I was studying in NIT Jalandhar. So we are also organizing these kind of fests, cultural fests, and it is kind of feeling like nostalgic to see the campus and the way the students are interacting, the way the fests are conducted. It's really nice and very refreshing session it was. Uh, so quantum computing is now a very I would say nascent stage. So we are stepping into quantum computing uh, everywhere. It is if you look at the recent market trend and the technology trend, you will find generative AI data science is everywhere. But quantum computing is taking leaps in the back end slowly. But I'm sure in 3 years, you will see it as a major trend, major market technology trend, and we should be prepared for that. And every nation all around the world is trying to be the dominant force in quantum computing because they know already that quantum computing is the future. So whosoever owns it, whosoever becomes the winner, he will dominate in the whole world. So that is the promise of quantum computing that scientists are expecting. So it's better to get started with this technology as soon as possible. And I'm glad that all students they are showing interest, a lot of interest in participating in this kind of fests in large numbers. That is very inspiring and very amazing to see and witness. Having said that, I hope I gave some good insights into the quantum computing and quantum algorithm. I know that it's uh, in such a short span, 1 hour or something. It's not easy to understand and grab everything. But yeah, I'm sure you would have definitely got some ideas about how these systems work. You can utilize that to explore further about this technology and go ahead and maybe who knows you may be the winning horse in this race. Thank you very much.
Every great event has a moment that shifts the entire trajectory, a moment when a legend steps onto the dais. And today is that moment. We are not just about to hear a lecture, guys. We are about to receive wisdom forged in the crucible of extreme leadership, digital welfare, and cutting edge research. Our guest is a scholar warrior whose resume reads like a national defense playbook. He is an alumnus of both the elite Indian Military Academy and IIT Delhi, a dual foundation that is simply unmatched. For 2 decades, he dedicated his life to national service, rising to command two critical ICT units, overseeing a diverse high stakes team of 900 people in operational environments. His strategic brilliance and decision making under pressure protected personnel and assets even though the height of COVID-19 pandemic. And for that very distinguished service to the nation, he has been formally honored with the Vishist Seva Medal by the Government of India. But while he mastered the art of command, he simultaneously redefined the boundaries of intellectual curiosity. He's a certified master of ethical hacking and forensics, an instructor who has personally trained over 100 specialists in cryptology and cybersecurity. And now, he is not just talking about the future, he's building the defense for it. He's currently pursuing his PhD from IIT Kharagpur on the most forward looking topic imaginable, and that's post quantum algorithms. In the civilian world, his impact is measured in massive national scale infrastructure. He's a master of information security, GRC, and ICT project management, a specialist who can design and implement data centers from the scratch. When we talk about scale, we mean scale. He has planned and executed complex national ICT projects exceeding 900 crore rupees. He moves seamlessly from tactical strategy to policy formulation, from the battlefield to the digital frontier, and now he is here with us. RGKT Srikakulam, Qiskit Fall Fest 2025, and the entire participants, prepare yourselves for a mind that operates on the boundary of what's possible. Please join me in extending the most massive virtual welcome to the architect of security, the recipient of VSM, the visionary, the one and only retired Colonel Sri Sai Shankar P. Sir, the virtual dais is all yours.
First of all, I would like to express my sincere gratitude to Srikakulam for inviting this talk. Before going to the topic in particular, today I am very, very excited because around 22 years back, I did my engineering from Parvatipuram, which is very near to Srikakulam, and I belong to Vishakhapatnam. So this is like a nostalgic movement which has coming to me. So let's go straight to the presentation. I hope everybody is able to see my screen. Nikhil, can I start?
Yes, sir. Yes, you can proceed.
Yeah. So the topic in particular which we are going to cover today is I'm going to talk about from the industrial use cases of quantum technologies. I'm not going to talk about the science. I'm not going to bore you with the equations, nothing urgent. But what exactly this technology will be utilized by the mass world? This is what I'm going to be talking in particular. And you will be also a little bit mesmerized why images of Hindu gods are there on such a contemporary topic. So let me just clarify, it has nothing to do with Hinduism. I'm pursuing and studying quantum from the last 1 decade. And it has been seen again and again the number of questions which the Western mathematics is not able to answer. Hindu scripture, especially Vedas, are able to answer them. So this is the reason why these images of Hindu gods are there on this slide. And I'm firm believer of Dohet, which says that victory smiles upon those who anticipate the changes, not upon those who wait to adapt after the changes occur. So a visionary, a leader is the one who sees the future, take risk, and start acting on it. So before coming into the technologies in particular, I also well versed that from the last 3 days you are going through a series of lecture of quantum, but we will just have a basics of this science of quantum and why this all of a sudden the entire world is talking about quantum and quantum. And then after having understood this, we will just also see what are the applications, definitely what is the market size it is going to happen, and then definitely the question and answer. This is how I'm going to structure my talk. So if you see the entire history of humankind, the entire history of humankind is being divided into three main eras. And any country or any nation which master that era requirement is able to dominate the entire world. In the first phase, it came to the agriculture. And we have seen that how Indus Valley civilization and the Mediterranean people was able to dominate the world. And then they came the colonization. And any nation which was able to master colonization and industrialization, they were able to dominate this entire world. The classical examples of countries from the Europe. And third came the capitalism, and a nation which is able to master capitalism is able to dominate the entire world. Classical example is from the US, which understand capitalism and which is able to rule this world from the last 5 to 6 decades. After this three phases of era is over, the next phase is coming with the technological era. And a nation which has the IP or which make products on technologies will be able to master this world for the next 100 years. That is the reason why entire nations across the world are investing money in billions to get technology, to get IP, so that they can dictate the terms and conditions how the world should move. So, this is just a basics of quantum science. There is some issue with the video. The important point which I want that you should, the entire student, which you should take away from this entire talk is that whenever there is any technology, the technology has to be supported by some principles of physics. Okay. Today, whatever the laptop you're using, the mobile you're using, the satellite is there, or this video conference which is happening, they all work on the basic principles of physics which are called as classical physics. And around 1 decade back, when immense amount of computing power was happening, when people tried to achieve more computing power, things were happening on the ground, but classical physics was not able to explain. At that point of time, quantum physics came as a rescue, and all those technologies which work on the principles of quantum science are called as quantum technologies. So the point I'm trying to bring out is that whether you take AI, whether you take blockchain, IoT, 5G, you take your generator or anything which you take as on date, which is technology, your AC which is working there in your auditorium, they're all upgradation or works on based on classical technologies. Whereas quantum technologies belong to a separate vertical of science and all work on the principles of quantum physics or quantum science. So this is the basic distinction that you as a technical person should understand how quantum technology separates coming to the other sciences, classical science. Now, after this talk of 1 hour and after your 3 hours of your 3 days of your Qiskit program, which is happening in Srikakulam, if none of you understand quantum, it is not a big issue. This shows that you have a very high level of IQ. Richard Feynman, the famous professor from MIT, he stated that my students don't understand quantum because I don't understand. Nobody understands quantum science. Because the quantum as a subject is not to be understood, it has to be felt. It is not rational in nature. Things, our logic brain fails, but things start happening on the ground. This is how you have to see quantum as a subject. Now, as I was trying to bring out is that the two words which are associated with the quantum are exotic and counterintuitive. Means your logic will fail, but things will happen on ground. Over a period of from the last 100 years or 200 years, we have been fed with in such a manner till the time our logic does not satisfy in our brain, we do not believe what is happening. So unless and until somebody says that 1 plus 1 is equal to 2, it fits in my brain. And then I said, okay, this is happening. But nature, oblique quantum science, does not work in a rational manner. It is counterintuitive. So the point I'm trying to bring out is that our capacity to understand quantum science is limited. First of all, we have to feel it, absorb it as it is, and then try to understand what it is. So there are various terminologies that are associated with the quantum. But as from the technical people, we are not from science background. We are not from scientists. Scientist people are coming from Indian Institute of Science or ICER, Indian Institute of Scientific Education and Research. They are the core people who work on science. We come from technological institutes whose responsibility is to convert science into technology so that the masses can use it. And also, once the technologies are existing, how to run and maintain those technologies. That is what our responsibility. So, over a period of quantum subject, if you keep dwelling into it, there are number of definitions or terminologies that you will keep encountering. But if you understand these two terminologies, which are called as superposition and entanglement, 99.9% of your technologies will depend upon these two terminologies. So let us try to understand what is this two terminologies all about. So one terminology is called a superposition. Superposition is the ability of a system to exist in multiple states at the same point of time. I will repeat. Superposition means ability of a system to exist in multiple states at the same point of time. Let us try to understand with the help of a small example. On your left side, if you see a coin, if suppose there is a cricket match happening, toss is happening here, the umpire toss it, the output is either head oblique tail. These are only two outputs that I can achieve in a classical world. Whereas in a superposition world, not only head oblique tail, but I will get various combination at the same point of time. This is called as superposition. Let us try to understand with the help of another example. A great professor from MIT take an episode of Mahabharata and he explained this superposition with the help of this example, where ability of a Krishna to exist in multiple states at the same point of time. This is what is called a superposition. Again, for the sake of clarity, it has nothing to do with Hinduism and it has been not been taken into technology. It is just to make an analogy to make you understand. So I will repeat superposition, ability of a system to exist in multiple states at the same point of time. This is called a superposition. Now coming to entanglement, two states are entangled to each other. If I change one state, the other state immediately changes. So let us try to understand again with a small example. Suppose I take two coins, I entangle each other. One coin I keep in Srikakulam in your institute, and another coin I take with me in New York, wherever I want to take with it, I have taken it. And for the next 6 months or 1 year, we have no communication, no optical, no mobile communication, nothing. If I flip the coin wherever I'm located, immediately the coin at your location will get flipped. Now you will say, sir, how it is possible? From the last 6 months, we are not talking to each other. There is no optical communication. There is no communication. And you're saying miles distance, and at any point of time, it is getting flipped. As I brought out you, in quantum world, things happens on the ground, but you cannot put logic to it. Okay, we will try to understand with the example of another example. I don't know, you may be young generation. Around 2 decades back, there is a movie of Nagarjuna came, which is by the name Hello Brother. In this, where two twins were there. So one hero does anything, immediately the other hero will do it. That we can say a property of entitlement. Again, this property of entanglement is taken by this famous professor from MIT and explain entanglement in this manner. Again, episode of Mahabharata. Here, the character Sanjay create two entangled states. One entangled states he keeps at the battlefield. One entangled state he keeps in his mind. Whatever the changes are happening in the battlefield, the same changes are happening in his brain, and he is able to tell this entire pictures to his king. So both the phenomena, superposition and entanglement, are physically achievable. There are a number of labs in India we can connect offline where we can make a trip of you guys and you can physically see how these things are happening. Now, coming from a technical point of view, in entanglement is that suppose I take two electrons and entangle to each other, I separate the distance of it. If I change the spin of the electron from clockwise to anti-clockwise, immediately the other electron, which is separated with a far distance, it will change its direction. So whatever changes are happening in one electron, similar changes are happening in other electron. So just to summarize again, these two terminologies are so important. As I brought on, 99% depends upon this terminology. Superposition, ability of a system to exist in multiple states at the same point of time. Entanglement means one state totally depends upon another state. If I change one state, the other state immediately changes. So now we have understood little bit about science and little bit about their terminologies and also why the world across the world are getting crazy and investing in the field of quantum science to convert into this technology. So quantum technologies, it is not that a quantum technology can do everything in this world. No, it basically falls in four verticals, which I will talk with. One vertical is the quantum computer and applications. This is where the interest is gaining. So similar to your classical computer, your laptop and your mobile, there is something called as a quantum computer, which work. qubit. And their application, like this video conference is one application which runs on classical computer. So you have application which run on quantum computer. So that is one vertical. Second vertical is quantum secure communication, means one of the use case of the quantum computers break every level of encryption. How to safeguard existing encryption to quantum attacks, that is called as quantum secure communication. And third vertical is called as quantum sensing and metrology. And fourth vertical is called as quantum materials and devices to support this above three verticals. So as on date, other than these four verticals, there are no other areas where quantum is going to do a mass effect. So now coming to the important topic of everybody, which is how you introduce to the quantum. The point I'm trying to bring out is that quantum as a subject is not limited only to computer science and electronics and communication people. Even the people from chemistry background, physics background, meteorological background, mechanical background, it is applicable to everyone. We will see one by one how it is there. So quantum computer is the one of the first use case of a quantum technology. Let us see what it is. Yes, similar to your classical computer, your computer or a mobile is of 64-bit. That is consists of classical. Whereas a quantum computer work in the principles of qubits, which is called as quantum bits. A classical bits can be in ones and zero, whereas a quantum computer work on principles of quantum bits, which work on the principle of superposition, which will not only in the state of ones and zero, but a combination of ones and zeros also. This is what is called as quantum computing. So many times you must be hearing quantum computer has so much of computing power. How it is feasible? Let us try to understand with help of a very, very small and meaningful example. Suppose there is a lock and this has three position and the number of combination that is possible is 000 001 like this triple one. These are the eight position which are feasible. Okay. And let us assume that the key is triple one. The password to this lock is triple one. Now I have put in my cycle and locked it. A classical thief comes, since he does not know the password, he will use a brute force attack. So in a brute force attack, what he will do, he will apply one by one. First he will apply 000, then he will apply 001. At the eighth attempt, he will be able to break it. Because okay, now after this a quantum thief comes, he comes with a quantum computer. Because of superposition, this all eight states are available to him at the same point of time, and he will put it and he will be able to break this key in one attempt. This is the reason why a quantum computer has such amount of exponential computing power compared to a classical computer. A classical computer, how much you put HPC or how much amount of computing power you use, number of processor also, because of non-availability of superposition, it can never beat a quantum computer. I hope this example will make you understand why a quantum computer has so much of computing power. So Professor David says that a quantum computer has the potential to solve problems that would take a classical computer longer than the age of the universe. Okay. And recently in June 2025, Google has launched a paper called Willow, where they were able to solve a problem, complex mathematical problem in 5 minutes, where a supercomputer will take 10 to power of 25 years to solve it. And just to compare, the Earth age is around 10 to power of 15 or 10 to power of 16 years. So even though the age is greater than it, that's how quantum computer can solve. And let me tell you, the quantum computer is still not mature. It is still coming up. That is the power of quantum computer. So, and this slide is also very, very important. This gives you a lot of clarity. It is not that a quantum computer can do everything on this under the sky. It is not like that. And it is not that a quantum computer is going to replace your classical computer. A quantum computer, as on date, can do three things only very well. There is no paper exists where a quantum computer can do better other than these three things. One is the simulation, one is the optimization, and one is the search. Under simulation, it can do a faster and subatomic simulation. And three verticals are coming as the use cases at the new drug discovery, new chemicals, and new materials. Whereas the optimization problems are like quantum finance and logistics. And in the search, where I'm able to do like a brute force attack, I'm able to break every level asymmetric encryption. This is what. Just to repeat again, a quantum computer can do three things only very well. It can do simulation, optimization, and search. Under these three verticals, these are the various few use cases which a quantum computer can do in an exact manner. Now, these are the few additional advantages of a quantum computer. I request the audience, please go through it once. So basically, it is like that a quantum computer can do a faster uh, compute, and it can do a compute or the simulation at the subatomic level. So depending upon this, the number of use cases, you can do it accordingly. So now, sir, we have heard about it. The audience may be a little bit be asking, sir, you are saying that there is a property called superposition, there is a property called entanglement. Can I achieve it very, very easily? No, it is not very easy to achieve this quantum properties. To achieve quantum properties, you require a unique environment. This is one of the environment how you can achieve it. You create an environment which the earth magnetic field is 50,000 times as less as them. The pressure should be 10 billion times lower, and the temperature should be as low as 20 mK. When you create such type of environment, your electrons or photons start having predict or exhibiting the properties of quantum. And let me just tell you, this is only one way of achieving a quantum computing or property. There are other ways are also which we call as NV center, diamond, ion trap, photonic. So there are vertical. This is how you do a superconducting quantum computer. So similar to your mobile or laptop, which is a 64 qubit processor, this is a 4 qubit processor. Now we have 100 or more qubit processor. And if you go in the background, if you see it, you see that is the type of environment it is created. The atmospheric pressure is as low as a proton. The magnetic it is protected from a magnetic Earth's magnetic field 50,000 times. The temperature is as low at 10 mK. When you create such type of environment, you can make electron, proton, or photons to exhibit the properties of quantum properties. And also, I will repeat that this is not only way of achieving quantum properties, there are other ways of achieving. Since superconductivity is one of the ways. So this next few slides will show you that quantum computer or this thing, it is not only limited to scientific journals or scientific papers. It has started going in a big POCs or proof of concept in a lab environments. And from the lab environment, it is going into the mass environment. So these are just of the slides which shows that quantum technologies is not in an perception or in imagination, it is happening on ground. So this is the D-Wave quantum computer. One of the first quantum computer came from University of Waterloo, which is located in Canada. This is, I think, if I'm not wrong, it is a 7 qubit. It's almost half of the size of the auditorium or a football ground. So now we have understood why quantum as a technology, the entire world is going crazy behind it. And also, what are the few use cases of quantum computing? Let us try to dwell few more things on. One more point I want to highlight is that as a told, quantum computer can do many things. One of the thing which is can do it is has the ability to break every level of encryption. So once the quantum computer has the ability to break every level of asymmetric encryption, the entire world got crazy. And they said that if the encryption is broken, the entire IT infrastructure will be broken in a days. Because today, if you use any application on the internet, it uses encryption. So how to safeguard it? At that point of time, quantum came as a rescue that is called as quantum secure communication or quantum cryptography. This is the second vertical. To summarize, quantum cryptography is nothing but to upgrade the IT infrastructure to in such a manner that it can withstand the attack of quantum computers also. That is called as quantum cryptography. So as I was trying to bring out is that this was the June 2025 paper. quantum computer was able to, willow chip was able to solve a complex mathematical problem in 5 minutes, whereas supercomputer will take 10 to the power of 25 years to break it. Okay. So one of the first use cases which I said that like Grover's or Schroeder's algorithm, which they will be implementing, ability to break every level of asymmetric encryption. And today, just for your information, who is from the electronics background, computer science background, one who had read computer networks, so they must be learned something about RSA. So RSA, to break RSA, it will take 300 trillion years to break it. And then the entire world thought that we are safe, and we have started using this RSA, all types of encryption, asymmetric encryption from the last 2 to 3 decades. But a quantum computer can break in 1 or 2 days. If it has the ability to break 1 or 2 days, then the entire world will be in a big mess. So there is a requirement how we will upgrade our IT infrastructure to quantum safe. So the critical infrastructure of any country or any country nation is that BFSI is the banking finance sector, transport sector, telecom sector, power sector, defense sector. So all the sectors are users asymmetric encryption. The point I'm trying to bring out is that irrespective of the sector, irrespective of the platform, irrespective of the application, if you are using internet and providing security in some manner like HTTPS, they are vulnerable to quantum attack. So if that they are vulnerable to quantum attack, what are the security measures? So you can upgrade your quantum infrastructure to quantum safe by using two methodology. One is called as quantum key distribution and another is called as post-quantum cryptography. Okay, so quantum key distribution is nothing but it is a key distribution at two places. So generally people use Alice and Bob. I am not fond of them. I use Indian names like Ram and Lakshman. Suppose Ram is sitting in Srikakulam and Lakshman, suppose I am sitting in Hyderabad and we want to generate a secure key. So even to any eavesdropper over the internet is not able to do it. So what, because of the superposition, Ram in Srikakulam will do some changes on its electrons. Immediately those changes will happen to me, Lakshman, in Hyderabad, and I will be able to generate this key. So to summarize that, quantum key distribution uses the principle of superposition. It is nothing but generation of a secret key between two places. Other than this, quantum key distribution is nothing. Okay. Now, this is one of the PTD system that was developed by China. That's a satellite called a MICUS. It was able to do this program in 2018. One point here I want to highlight is that uh, we as a nation, how the world sees us. The world sees us as a service, as a labor. Okay. And I openly says it that before independence and post independence, I hardly see any differences. Okay. Today, also many Indians, especially Andhra, or I can say that what is our ultimate goal? Ultimate goal is to do some engineering, go to US or Europe, settle down there and work from them. This is how we said that. Whereas the China as a concept, they said that they're world-class PhD postdoc, they go outside, learn in outside, then come back to their nation and develop it. The point I'm trying to bring out is that a nation can develop only when its good, strong peoples work in that nation only and develop it. So many people will say that, sir, this nation does not have an environment for my expertise, so I have to go it. So again, I bring out the point, what is nation? Nation is nothing but you and me. If there is some issue in the nation, you have to solve it. And if you do not solve it, how you expect the next to next generation will have a better environment? The point I'm trying to bring out is that when the entire world is having this watershed movement, you do your studies, you learn whatever you want to learn, but your thought process should be always be like this: how I can contribute to the nation. You go to big companies. I don't want to name it, but many people say that this big company CEO is this our Indian accent. How does India get benefited? It does not get benefited in any matter. India as a nation will benefit when you work here and make a technology and develop it, give it to the masses. Second problem is that as a nation, we are only producing services. And a service oriented nation cannot be strong. Today, other than Joho, which we have recent example, we are the biggest IT service providers to the world. But how many products we have? You take WhatsApp, the video conference which you are using, anything which you are using as on date, 90% are done by Indians only. But how many owns them? So if you have to be strong, or at least if you want your next generation to not to be dependent with a begging ball with others, you have to make this country within self-oriented. B to generate IP. Okay. So now coming to back to the topic is that quantum second vertical, how you will make it the quantum safe is through using post quantum cryptography. Post quantum cryptography has nothing to do with quantum physics. It is based on the pure principle of mathematics like RSA, elliptic curve, and Diffie-Hellman. Okay, so quantum key distribution is media dependent. You require optical fiber, free space. Scalability is a big challenge. PQC is non-media dependent. Scalability is not a challenge. Depending upon the use cases, you can implement. Generally, people go with a combination of both QKD and PQC. That depends upon the requirement. To this slide, you can have said that if I have to make that IT infrastructure quantum safe, that quantum computer cannot break it, I should make it quantum secure. And to achieve quantum security, I have two mechanisms. One is quantum key distribution and post-quantum cryptography. So US is very, very serious with the post-quantum cryptography. They have a law, they don't have a guideline also, that by 2030, the entire IT infrastructure should be upgraded to quantum safe. Okay, so we have seen one vertical of quantum computer. We have seen one vertical of quantum technology, that is quantum secure communication. Now, third vertical is called as quantum sensing and metrology. Okay, before GPS came into action, we used to use gyroscope to navigate. Okay, and but they were not very, very efficient. It was not accurate. We shifted to GPS. Okay, and before gyroscope was there, was that how birds used to navigate. You must be aware that Odisha Chilkur Lake is very close to you, Srikakulam. So you must be hearing that news that every year birds migrate all the way from Atlantic, North Atlantic, and they come and they go. They do not have a GPS. Then how they navigate? They have the navigation with the ability called as quantum navigation. This is what by using quantum technology we can implement quantum navigation. Okay, so quantum navigation is nothing but ability to measure the electrical and magnetic field with a very, very high level of accuracy. So today, if I can measure electric and magnetic field very high level, then the use cases will come. One of the first use cases is the GPS free navigation. Okay, where you can navigate without GPS, like submarines can navigate without GPS with the quantum navigation system. Your airplane, fighter aircrafts can navigate without a GPS, or they can have an initial navigation system. Okay, and today also we are using big amounts of clocks for synchronization for the entire IT infrastructure that are called as atomic clocks. We can have quantum clocks which are very, very precise. In addition to this, once you have a capability to measure high level of electric and magnetic field, which is called as gravimeter or magnetometer, you can ability to make MRIs also. Today, your brain or the body emits electrical signals and magnetic signals. This electric and magnetic signals are very, very weak, where a normal sensors like MRI cannot detect it. Where if I make quantum based MRIs, this can detect this electric and magnetic field very, very precisely. And the future cancer attack or dementia, whatever happen, I can predict it. This is what can be done. Okay. And one of the beautiful use cases of from the defense perspective is called as quantum radar. It works on the principles of entanglement. Let us try to explain with the help of small example. I will not go deep into the physics. On the left side is that how a radar works. Radar works is that there is a base station. It fires an signal that the target will reflect the signal, and then the base station will another station will receive it. Now suppose it is a stealth aircraft, it will absorb the signal, then it becomes very, very difficult to detect that stealth radar. So there is something called as a quantum radar. In the quantum radar concept is that again it uses the principle of superposition, entanglement, sorry. It will create two entangled photons. One photons I will fire towards the target, and another photon I will keep with myself. And whatever the changes are happening at the target because of entanglement, same changes are happening at my location also, and I will be able to detect the target. So let the target absorb it, deflect it, doesn't make any difference. This is how the quantum radar works. Just go through the slide once again. If you see whatever the technology has spoken, whether it is quantum computer or quantum communication, everybody work on the principle of superposition and entanglement. This is again, and this is not a fiction. People are able to implement in lab environment. And third use case is called as quantum sensing or quantum enhanced cameras, where the ability to see beyond the walls. Suppose a Taj Hotel incident happened where the terrorists were able to kill many people. They were sitting inside the hotel rooms, and the security forces cannot pinpoint where the terrorists are sitting. So, suppose I have a quantum camera. I sitting outside the room, I will fire the photons and it will go inside the room. It will interact with the target, and because of entanglement, similar changes will happen to the camera which is located outside the wall, and I will be able to map the entire room. So this is how again a quantum camera work, ability to see around the corners or behind the wall. This is how entanglement based quantum cameras works. So now how do you analyze a nation ki which is the area that I should work or that some? If you monitor the amount of publication that is happening on this field, that you can measure. So number of publications that are happening in the field of quantum are increasing tremendously in the last 1 decade. So this is that okay, this is where the science is going to convert into technology. Now coming to the funding. So this is a McKinsey report. Across the world, everyone is investing to convert this science into technology. Okay, so across the world, everybody is serious. I brought out everyone want an IP of this technology, so they have this ability to dominate the world for the next 100 years. So this is just an yearly budget of the various nations. So this is again so the amount of market that is going to capture by 2035 is around 2 trillion. Let the world sees how it is going to happen. Now coming to the national level, we have talked about the international level. Now we're coming to the national level. So how? Here theories are our theories are world standards. And if you get a chance, you go to Singapore or you go to across the world. Major of the people who are working on this workforce is the quantum is the Indian manpower. But we seriously lack experimental mindset. And as I brought out, we do not have any product mindset. My entire aim is that how I complete my engineering, how I should get into a big company, and immediately how I settle down to US and get money in dollars, and how I work for another company. As a nation, we do not have this mindset that the product oriented mindset like Atmanirbhar. Today we are coming, everybody is Atmanirbhar trying to bring out. So this we have lost our generation. We did not had this opportunity 20 years back when I was doing my engineering from Parvatipuram. But today you are having that golden opportunity. The watershed movement is happening where you can make products. So at least you not you next to next generation will be benefited. And India is very serious in this, like other nation. We have a national quantum mission of 6,400 crore, which is being given to various IITs, R&D institutes, academic institute is giving. You guys are very lucky that you are working under, I generally don't talk politics, but your state is doing something which is making the world jealous. Your state has something called as Amravati Quantum Valley. It is already has an investment of 100 million USD. Similarly, Karnataka as a state has invested 1,000 crores, and other states are also in the pipeline. And some guidelines are given by the certain. So yes, India is also very serious in this. Okay, just to summarize the entire talk, that clarity should exist is that quantum technology work on the separate principles of physics that is called as quantum science, and it is a separate vertical. It is not like AI, blockchain, which all depends on your classical physics. Unlike quantum technology can be divided only in four vertical. One is the quantum computer and its applications, simulation, search, and optimization. Quantum secure communication, quantum sensing and metrology, navigation without GPS, mine detection, MRI, and quantum materials and devices to support about four verticals. So, just quick overview about my company. Presently, after retirement in serving in India for 22 years, I presently technical advisor with National Quantum Mission, and I also started a company by the name Q Clarence Quantum Labs, which is located in Hyderabad, and we are going to start very soon in Amravati also. So these are the we work in two verticals. One is that the entire world is developing quantum computer. We are developing applications which run on quantum computer. That is our first vertical. And second vertical is quantum secure communication, which we are going to launch few products very soon. Okay. And now to conclude is that this is the watershed movement is happening. If you get into this with a product mindset to keep the nation first, then definitely your next to next generation will be very happy, or we will not be less dependent as the way we are. So I am firmly believe is that a nation strength depends on what it can do on its own and not what it can borrow from others. That is it. And this is my email ID. This is my mobile number. I request the audience to note it down. We are open for internship, both remote and physically. Hyderabad, and subsequently we are going to start in Amravati also. Please approach us. If you have a passion, if you are having a high level of integrity, high level of hard work, intelligence does not matter. We have an opportunity for you. That's it. So, Nikhil, I am done. I'm open to question and answers.
If any one of you are having any question and answers, please feel free to ask. From the participants, anyone? Just a minute, sir. One of our participants is having a question.
Yes, I cannot see your screen.
Hello, sir.
Yeah, Jay Hind.
How can a quantum sensor, which is from quantum sensology, can able to detect miniature signals? Why normal sensors can't able to detect? Is it about the material
Yes.
inside it or any other?
Okay, very, very good question. Because the quantum sensors have the capability to measure or to at the subatomic. Today, what is happening? Whatever sensors you have, you measure at the molecular level. Whereas the quantum sets work at the subatomic level, and we are able to measure the movements of atoms and photons also. Okay, that is the reason how I am able to detect those sense that capability to such a low levels. If you get a chance, try to visit one lab is there in Hyderabad, which has made ultra cold atoms, and these ultra cold atoms are able to detect this magnetic and electrical field signal at a very, very low level, which a classical sensor cannot exist. So I can just answer to that level. It is a very deep topic in particular. You can have my mobile number. You can always reconnect to with us, and we will be able to explain how a quantum sensor able to sense at a such a level. Basically, they have the capability to sense at the subatomic level. To just to summarize.
Thank you, sir.
Do anyone of you have any more questions? Uh, so it seems like that's all the questions they have. And for your insightful session on behalf of the entire RGUKT Srikakulam and the Qiskit Fall Fest 2025 organizing team, we are really, really grateful for your extraordinary and enlightening guest lecture, sir. Your session was a true intellectual masterclass, blending clarity, depth, and insight to make the most advanced concepts in quantum science accessible and engaging for everyone. The way you connected ancient wisdom like Mahabharata's Rasalilas for superposition with cutting edge science from institutions like MIT and Oxford was truly inspiring, sir. Your comprehensive overview of the four pillars of quantum technology was really invaluable. And the coming to quantum computing, highlighting the transformative potential of superposition and entanglement with real world applications in drug discovery, finance and encryption, quantum communication, quantum sensing, and quantum radars, showcasing practical advantage in low light imaging and its strategic significance for defense and security. And furthermore, your lecture provided a very crucial strategic perspective detailing major initiatives like India's National Quantum Mission and the ambitious Andhra Pradesh Quantum Valley project. Your meticulous explanations, practical examples, and engaging delivery ensured every student gained immense clarity and inspiration for sure, sir. The session was truly power packed, enlightening, and inspiring. We once again thank you so much, sir, for sharing your time, effort, and profound wisdom. It was really an honor to have you with us, and your guidance will continue to fuel our journey in quantum science, definitely. Thank you so much, sir.
Once again, thanks a ton to Srikakulam for inviting me. Jai Hind. Jai Hind.
Jai Hind, sir. So, to all our dear participants, whoever is listening to all these guest lectures in person or in virtual mode through live, also, please fill out the feedback form to confirm your attendance as well as give your valuable feedback. And you can have a peaceful lunch right now. Post lunch, we will be proceeding with the hands on workshop from Dr. Gnan Yala, sir. So, hopefully, I request you all to be right back after your lunch with all your things ready and with extra energy as yesterday. Thank you, guys.